Bonjour. Welcome everyone. Bienvenue à tous et à toutes. Je suis très heureuse de vous accueillir aujourd'hui chez Shopify dans notre bureau de Montréal. Le thème de la conférence est l'intelligence artificielle et l'équité des algorithmes. Comme vous le savez, en apprentissage automatisé, les algorithmes apprennent à partir des données qu'on leur fournit. Or, ces données sont souvent générées par les humains et malheureusement, les humains peuvent être sexistes ou racistes, ce qui fait que c'est très possible qu'un algorithme puisse apprendre à être sexiste ou raciste à partir des données qu'on leur a fournies. Pour contrer cette éventualité, on a créé à Shopify un code de conduite du machine learning ainsi qu'un comité d'éthique du machine learning. Et nous voulons sensibiliser notre communauté à ces enjeux. C'est pourquoi nous avons la chance aujourd'hui d'entendre parler d'intelligence artificielle et de ces enjeux éthiques par un grand expert. Professeur Yoshua Bengio est très connu pour son travail de pionnier en apprentissage profond. Il est détenteur d'une chaire de recherche du Canada et est à la tête du MILA, l'Institut des algorithmes d'apprentissage de Montréal. Il conversera avec David Lennie, le vice-président senior de sciences des données à Shopify. Originaire d'Iowa, David a quitté Netflix pour joindre Shopify au Canada en 2015. Et bien qu'il parle un peu français, nous ferons le reste de cet événement en anglais. So, welcome everyone to Shopify. I'm very excited to see you all here today. We have in the audience machine learning practitioners, students, and journalists that all share this interest for artificial intelligence and fairness. Algorithm fairness is something really close to my heart. Over a year ago, a handful of Shopify employees got together to discuss how human biases, such as sexism and racism, don't belong in algorithms. We decided we should treat such biases as bugs. We debug our code before we ship it, and when we find a bug, we fix it, right? To help us on that journey, we crafted a machine learning code of conduct that everyone within Shopify has access to and can consult and use, and a machine learning ethics committee to spearhead initiatives related to that subject. And what a better way to raise awareness around machine learning ethics than to have a high-profile speaker share their thoughts on the subject with us. So we are very happy to have Professor Yoshua Bengio with us today. Prof. Bengio has a rock star status in the artificial intelligence community. He is particularly well known for his pioneer work on deep learning. He holds the Canada Research Chair in Statistical Learning Algorithms and is the head of the MILA, the Montreal Institute for Learning Algorithms. His goal is to uncover the principles giving rise to intelligence through learning, as well as to contribute to the development of AI for the benefit of all. He will be chatting with David Lennie, Senior Vice President of Data Science and Engineering at Shopify. David has a wealth of experience and knowledge in building data teams, warehouses, and analytics teams. He is passionate about AI and fairness and leads the teams building the future of artificial intelligence in commerce. An Iowa native, David left Silicon Valley to join Shopify in Canada in 2015, and although he speaks a tiny bit of French and is continuing his studies to become fully bilingual, we will do this fireside chat in English today. And with that, I'd like to welcome Yoshua and David to the stage.
Merci Françoise. That's my un peu la français. Yoshua.
Okay, got it. Yes.
Yoshua, thank you for coming today.
Hi, David.
Yes, hello, and thanks to everyone else who is not from Shopify who's visiting today as well. We'll get into just kind of right into the questions, and then I think we're saving 15 minutes at the end for questions from the audience. So it'll be like a wild card round at the end. So maybe you could tell us just a little bit about yourself, Yoshua, and sort of more specifically, what are you working on these days? What are you most excited about?
The AI field has been making a lot of progress in perception, the ability to understand things like images and text and sounds to some extent. and also a lot of that progress and the kinds of things you guys are doing and most of industry is doing is based on supervised learning, where machines basically are trained to imitate humans. But we are able to learn in a more autonomous way, in a more unsupervised way, or with some rare feedback. So this kind of learning is something that's at the frontier of research in machine learning these days. And it's more like if you think about how a baby learns, like a baby doesn't really need to go to the university to learn about physics. She just observes things, plays with things, pushes things around, and she figures out what we call intuitive physics. So it's an understanding of pretty much all of the important things about physics without all the math, right? Her brain does it. So that kind of learning is, and also another thing she does is she goes after knowledge, right? So she gets bored and she tries to move herself into situations where she will learn. So this is very, very different from the kind of learning that we're used to in machine learning and classical statistical methods. So we're building virtual environments like video games where these learning agents are trying to do these kinds of things. So that's what gets me excited these days.
What are going to be some of the, you think the biggest leaps that need to happen to kind of realize that vision? I know that also there's been a lot of discussion recently about sort of the machines we lack an understanding of causality.
Yes, absolutely.
And that's I know you talked
connected.
about that.
Absolutely. Thanks for asking. So another problem with the traditional passive observation of data is it's hard to get a handle on the cause-effect relationship. It's much easier to find out about cause-effect relationships if you can do experiments like, can I try this and see what happens, right? And in fact, there's even math, showing that you can't really, in principle, figure out causality if you're not intervening. Of course, there are many things we understand without intervening, like we understand about planets, but we don't move planets around. But we use analogy with the things we can move around, I think, in order to figure out the causality, and then we extrapolate. So causality is something dearly missing from what we're currently doing in machine learning. And it's also about another limitation that's connected to all this is currently, if you look, for example, at the language part, I know companies like Shopify deal with natural language, and many companies, interfacing with human beings, have to either build systems that can make sense of what people type or say, and then generate responses. The problem is that most of these systems don't understand what the language refers to. So a lot of the traditional approaches in machine learning to deal with language is you train with tons and tons of texts. Maybe if you're doing machine translation, you're going to have millions of translated pages or sentences, but never really getting a hold of what these sentences refer to in the real world. So a lot of what's going on now is trying to both learn about how the world works. This was the thing I was talking about before, and also how the two-way translation between things happening in the world, actions, objects, and intentions, and so on, and causality, and how we express that with language, rather than just studying or analyzing lots and lots of texts, which eventually is limited. We're building systems maybe on a smaller scale that combine language with what refers to and a good environment for this would be things like virtual environments, and for example, to build systems that can do actual dialogue. I think this is going to be really important.
One of the things that strikes me, like when that question started with the causality, but then as you described some of the capabilities that need to exist. What I've kind of noticed, and I've seen the space moving toward, is research that's focused more on sort of, I think, sort of building some of those capabilities first, and like sort of the causal understanding, maybe the sort of the ultimate outcome. But we have to sort of like, build a lot of underlying components, like the ability to extrapolate, the ability for like the child who's learning kind of sort of intuitive physics, but then also is able to kind of make this mental leap and say like, oh, this system that I understand here operates a lot like this other one over here.
Yes.
And I feel like right now we're still not able to do that or achieve that with computers in a general way.
Yeah, so another analogy that's connected to what you're talking about is schooling. So before a child goes to school, where they'll be taught things sometimes in a way that's abstract, like they're going to read a text about some piece of knowledge. This is not the real knowledge. It's a representation of it in English, say. Before the child goes through this, she has to learn about the basic concepts in the world, right? The people, objects, and social relationships and intuitive physics, and to name those things. And now, when she reads a sentence or a story, she builds with her imagination a representation of what that story means that's connected to her personal experience, right? So she imagines herself going through the steps of the main character or something. But it wouldn't have been possible to do that if she hadn't first anchored her understanding of the world and associated, the language with that, rather than the way we're doing it now, which is, I'm going to feed you lots and lots of data and texts, and hope that you can find relationships. But so there's a thing connected to causality, which is reasoning. And it's been, the big thing with classical AI was the hope that we could build systems that can reason by laying down all the knowledge and then using modus ponens, so the standard logical methods for reasoning, in order to connect the dots and produce answers through a sequence of logical steps. But it doesn't work because those descriptions of facts and rules are imperfect, and they're not connected to the reality through like in the way that a child does, where the perception is connected to abstractions, and then the abstractions are connected to language. So we have to first train maybe those simpler systems that can start dialogue in a simple environment. And then once we have the right learning procedures for them, we can expose them to more complex real environments, starting to actually dialogue with real people. And just like children, then they can learn more complicated things about the world. But we have to start from the bottom up. That's what I believe.
Which is interesting, because so if we go kind of back into your history, one of the things that's sort of differentiated yourself, Professor Hinton and others, is you sort of took the path less traveled. You were very interested in sort of modeling, or using computers to sort of behave like, or model it on sort of how the human mind works.
Inspired by.
Right.
Yes.
So can you comment a little bit on sort of, do you feel like you've been proven right, or like how much are you still inspired by that today? I know I've seen some recent talks by you on sort of bridging the gap between neuroscience and sort of AI, but maybe you could talk a little bit more about how important that has been.
Well, I gave a talk recently about a list of all the ways in which deep learning has been inspired, and including modern deep learning, has been inspired by things we know from the brain, either from neuroscience or from cognition, and there's a pretty long list. I'm trying also to give back, so in other words, to use the abstract theories that we have built with deep learning as a inspiration for neuroscientists to test hypotheses about how the brain learns. Now, that being said, this interface between brain sciences and AI is still very thin, in the sense that very few people do it.
A few people did it before, when it was just yourself
That's
and a few
right.
others.
It's still true, because there's so much money to make by taking the current science and bring it to to products and services. So it's very tempting to be greedy, even in labs, in universities, and look for ways to combine our knowledge of mathematics and computer science to directly try to find solutions to our problems. Whereas sometimes I think you have to bite the bullet and think, okay, so this is actually a hard problem. Maybe it's going to take 20 years to be solved, and how do we get there?
But I guess on another way to view that, though, is that maybe it's a good thing that there's not more of a financial incentive, because especially when on the backdrop of sort of bias and ethics.
Yes.
I know that I've read some recent interviews with you where you've discussed that having the needing to take time to focus deeply on hard problems, and this is one area where I think that it's probably in our best interest if some of this moves a little slower than faster.
Yes. But we need to, slower doesn't mean we don't act. It just means that we have to think well about how we are going to organize our society, our companies, our organizations, to steer in the direction that's going to be best for all. And maybe that means that we're going to slow down the growth a little bit, but we have to do it right, and we can't just rely on our intuitions. So that's a place where we need science as well, like the social aspects of things. We need studies, we need different scholars to think about it and disagree, and we need to have democratic debates sometimes because there will be political decisions involved. These things take time, and it takes that people get educated about those questions. It takes that people doing the science get educated about the ethical questions, the philosophical questions, the social impact. It's not going to happen like this, right?
Agreed. So I guess maybe switching into some of the questions now. So for companies that are working with AI, what do you think are sort of the biggest weaknesses that you've seen, sort of companies that are doing it wrong, or what are the most common mistakes you've tended to see in the application of this technology today?
Well, I would say it's simply being unconscious as an organization about questions that are far from our field of expertise. Like, I'm an expert in deep learning and so on, and I'm not a sociologist. Like, what do I know about that stuff, right? Or I'm a developer, and I'm an expert in deep learning software stack or something. What do I know about ethics, right? So it's just like a blind spot for many organizations and many people who are taking decisions about this, which I think is at the heart of the many problems. The other issue at the heart of the difficulties we're seeing is simply that there are different forces at play. So there's a short-term, profit maximization. Companies have to survive. They have to compete against other companies. And that force is pushing some companies to maybe cut corners. And, we've seen things that have happened with Cambridge Analytica and so on. I think it's an example, but I think it's happening all over the tech world. We've seen, I think, Google make pretty stupid mistakes about what areas they should engage, and that's created a backlash within their own best minds.
So this is like the military funding kind of?
Yes, okay. Yes. So it's a mistake for a number of reasons. It's a mistake because Google is a global company, and as a global company, if they want to have the trust of people around the world and not just in the US, I think they shouldn't engage in products or services that are going to be, targeted at the US military specifically. That would create the perception that they wouldn't be trustable companies for maybe, users in other countries. And then, of course, it's a mistake because the people who are developing that technology in house in Google have bought in this company motto, do no evil, and they have strong opinions about what that means. And it's not business as usual. It's choose where you want to work in so that it's, well aligned with your values. And other companies don't necessarily have that thing, but the people they recruited, and especially the AI researchers, they really bought into this. I mean, a lot of people I know. And so now for them, it felt like a bit of a treason, right? You can't have a motto where you say, we're going to act like this and then act differently.
Do you worry about do you think there's a lasting negative impact on the space that people are sort of getting the wrong idea about the potential of AI, machine learning, that because they have such high profile examples like these that could possibly kind of mischaracterize a lot of this opportunity for many future generations? Is that something you think about?
There's a danger, but I think the cure is not to hide it under the carpet. The cure is to do these things in the open and to do it right, and to admit your mistakes, right?
Good. And what's interesting to me also is that as you went through that list of sort of things that people are doing wrong, none of it was technical, right? It's all sort of cultural. It's sort of your habits, your principles, and I think that's one mistake I often see is people think that it's and there can be methodological mistakes and things that you're doing wrong technically, but so much more of this mistake starts with discussions and principles and the values that you share in your development teams themselves.
That's true. I think most of the mistakes are at a level of simply not having thought carefully about those aspects, as I was saying before. But there's also interesting technical work in fairness, transparency, and all that, right? There's a technical conference on this subject, and there's technical work, for example, to minimize the biases that a trained system could incorporate, because the data implicitly contains those biases. So I think there's plenty of opportunity both to make progress with respect to all of these ethical questions, both using our philosophical common sense and ethical thinking and organization, as well as contribute in some cases with technological advances that can help deal with some of these problems.
Sure. I'm sure you get those questions when you appear at conferences and other places, but so for the good actors, companies wanting to really start leveraging AI, developing with AI, what are some of the areas you recommend most frequently that people sort of go and work on, or does it really sort of depend significantly on what sort of business they're in? Or do you have a hit list of areas where you say, this is going to work really, really well, the research has been done, it's quite strong?
You mean from the point of view of being beneficial to society, or just in general good types of applications? Well,
let's start with the good applications and hope that the good applications benefit society.
Yeah, maybe that's the wrong path.
Well, yeah, maybe it is. That's, again, another one of those questions we should be asking all the time.
Right. So you're asking about what are promising applications of AI?
Yes.
Right. I don't know. I do equations in the sky. I don't do products.
Fair enough.
But
I'm just asking the questions on the page.
Yeah. I can try to answer in a fairly generic way.
Sure.
Nonetheless. So a very clear thing people have to keep in mind is one area where the progress has been most amazing in recent years is in the ability of computers with machine learning to both understand and generate images. So everything visual, we are incredibly better off than we were a long time ago. And this is enabling, many different things. Robots in factories are using more and more vision. self-driving cars relying on vision.
Sometimes overly reliant, but like.
Yes. Security systems, all kinds of user interaction now can take advantage of vision and will. So that's one place where it's almost like a magical thing that we have in our hand that we can use, and I'm sure there'll be lots of young people and entrepreneurs and engineers which will discover new uses for this. It's like it used to be that computers didn't have eyes, now they do, all right?
Yeah, fair.
So that's one thing. There's been and to some extent, it's also true of sounds, signals, any kind of thing you measure that's analog, like biomedical signals, signals from instruments, measuring things happening in your head or whatever. So there's lots and lots of applications where it's not pure standard images, satellite images, of course, speech recognition, that's, music. So all of these are kind of in the realm of perception. Mm-hmm. That's where really the progress has been most amazing. Another place that people may not be aware of, and is something that's starting, is the ability of computers to be a bit creative and to generate new things. This is something I worked on for many years, and we're now seeing pretty amazing results. The most impressive things right now are in the realm of images. People are starting to tackle videos, sounds, and so computers can now take inputs and then outputs that are things like images or signals and so on. This is also new and can open all kinds of doors. It could also be raising lots of ethical questions.
Right, I was just going to ask you
Fake news, for example, right?
Well, or even so the creative industries themselves, right? So the broader topic of just sort of job displacement.
Yes.
And so as machines get very good at even the creative enterprise.
Yeah. So one of my sons is a musician, and he's a composer, and so he dreads the day when machines will be able to compose music better than humans. And I don't know, maybe he's right, and we should be thinking about these things. My gut feeling about this is, even if machines are good at producing some things like that, we may still be interested in having the human touch. So maybe an analogy for this is, let's say you went and you could go and see a hockey game played by robots, and they're like so much faster and better than any human. Probably be boring, right? Like you want some real humans to lose or something, right? I mean, like you want some emotional action.
Yeah, there's some amount of connection also to the human condition. You're watching these people sort of succeed and fail in a way that you kind of identify with them.
That's
you
right.
see yourself as that
That's
person
right.
who can score the goal or whatever.
Another example in the same line of thought is if you buy a glass that's like this one, how much did it cost to produce this in some third world country? Probably like 50 cents or something. And maybe you'd pay a couple of bucks in the store. But if it was made by an artisan, man-made, individually, I think, and probably be nicer as well, but people are willing to pay $100, right? Because they know there's a human behind.
Interesting. One more quick question, we'll switch gears. So given like the rapid pace of AI development right now, if you look out 5 years' time, what do you think the world's going to look like with regard to AI, and are you hopeful for the future of AI?
I'm very hopeful. I'm like an optimist. But
if you said no, you'd be retiring right now.
So I think we are not seeing yet all the potential applications of these technologies. One area which hasn't moved as fast as some of us were hoping is the ability of computers to understand language. And so these personal assistants and so on, they kind of still suck, right? I mean, it's not so great.
A little rough around the edges.
I mean, so
right.
Google has a nice demo, but I don't really believe that if you were like in a free roaming interaction, it wouldn't really work.
Right, it could be deeply trained to do like that
Yes.
demo quite well.
And we know we can do that.
Right.
Very specialized systems, now they work. But sometimes you need a broader understanding of how the world around us works in order to have a real conversation. So I think we'll see more and more of these systems, but for many years it will be probably very limited to very specialized things like, I don't know, restaurant reservations, for example, which is the kind of thing they were looking at. Hopefully, in maybe 5 to 10 years, we'll start seeing systems that are a bit more, have a bit more common sense, having a more general understanding of people and society and so on.
Do you think that that is one of the sort of the ultimately most desirable form factors for a UI is sort of voice interactions, and that once it gets quite good, will drive a lot more adoption?
Yeah. Most people don't really want to go through menus in order to communicate with a machine. And the thing I've been thinking a lot for a few years is that if we make sufficient progress with those dialogue systems, it will open up the internet to hundreds of millions of people, billions of people who are illiterate.
Yep.
Or simply computer illiterate, right? So it could be a huge social revolution, that simple progress, which is not simple.
Right, no, agreed. So going to data ethics and fairness, what's drawn you towards your interest in algorithm fairness in general, or why is that an important topic to you?
It's not something I've really worked a lot on. I'm interested in the general question of how do we make sure that the progress in machine learning is going to be good for society and applied in good ways. And fairness is one of those areas where it's worth spending time. And I guess one thing that attracted me to fairness in particular is that I thought quickly that, we can actually do something technical, right? So, of course, there are social things like you could collect your data better, you could make sure that you keep track better of how the data was collected so that other people can check. Is it going to be representative, for example? But then the thing that I found really cool is the application of some algorithms we developed in my group called adversarial networks. Mm-hmm. In order to train systems which would be, by design, insensitive to particular aspects, like variables like gender, race, religion, or whatever you want to put in. That was not something I expected a few years ago that we'd be able to do that. And the technical solution to this is beautiful. I mean, like from a scientific point of view. And one thing that interests me in this particular aspect of fairness is it's actually something that governments could write regulation on tomorrow morning. I mean, lawyers take time to write things down, but basically we have technical solutions, and like insurance companies, for example, could use this. They will probably not use it, or maybe some will and some won't, unless governments say, okay, so this is the bar we're putting. You should use the state-of-the-art in machine learning for removing bias with respect to these variables, the usual ones we have in our constitution and so on. So this is all about execution of technical solution at a society level. It's feasible, and it could be like a first step, which is not going to hurt companies much in their innovation. It's actually force them to learn about something cool, which is these adversarial networks. And so it's a nice example that I use to show that we don't need to wait 10 years before governments can start regulating, but we have to do it right. We have to bring the industry actors in. It's going to be on a per industry basis, right? Because you have to think about, well, does it make sense, and do we have the right data for doing this? What is it we're doing? What is it we're protecting? So yeah, it would still take some work to do this, but I don't see any big obstacles, except that governments right now need to learn about this, and the industry, like say if it was the insurance industry, needs to sit down and get to know about what is that. I mean, they probably haven't even heard about what is an adversarial network, right? So.
Yeah, so one of the things that I've been thinking about with sort of regard to the modern kind of push for, I think we've talked about this, more transparency, more openness in how data is being used, so that people understand the costs of what they're giving up and also the value that they're getting. But I think one of the other challenges is the more transparent you are about how these algorithms work, there's also then a lot of threats to sort of like adversarial attacks.
Right.
That
Another cool topic.
And I think I'm not quite sure how to resolve that intersection because the solution.
There are technical solutions again.
Great. So please talk.
Well, so there are algorithms that people are developing, which even if you knew the algorithm, it would be very hard to attack, right? Things like you have a committee of neural nets that are taking decisions, and each of them only sees part of the data, and then they vote or something like that. And then you can have guarantees that if the data for one person was changed, there's only so much of the response that could change, and with what probability. So you can get guarantees about the privacy that is going to be enforced by such systems, and yet the algorithm can be out there in the open. So it's not always easy to reconcile these two aspects, but I think it's worth putting forward those questions so that researchers get a crack at them and we start seeing solutions. Right,
because that also then suggests one other problem, which is there are other solutions, but they raise the technical bar, the technical hurdle that's required to sort of ensure that you're safeguarded against this, which now also then makes these technologies and techniques slightly more or maybe a lot more out of reach of small places, small companies.
Well, that's where companies like yours come in.
Sure, right, leveling the playing field.
That's right.
Okay, fair enough. I did serve that up, I think, just for you to say it right back. So thank you. Let's see. How can companies build data ethic practices into their culture? And maybe you can even talk about I forget what the list of principles are from University of Montreal.
Right.
I forget what that document's called, but I think it's a good...
The Montreal Declaration for Socially Responsible Development of AI.
Yeah, it just rolls off the tongue. But maybe talk a little bit about what some of the guiding principles are there and why that's been important. Who's driving it?
So first of all, it's a collective effort. It's been initiated by philosophers, but there's people from social sciences, people like me, machine learning researchers, and as I said, like ordinary people giving feedback. And it's about trying to clarify what are the kinds of issues that applications of AI could bring up. And it's interesting, in the tour that has been going on, and there will be more going on in the fall, in libraries, so ordinary people are coming and they are being presented with some scenarios. Because it's hard to be very abstract with most people about these questions. If you haven't thought about something, you have to be concrete. So we've tried to come up with scenarios about, in 5 years from now, or 2025, you're sitting at home and then there's a self-driving car coming and whatever. So it's trying to build concrete things that people can imagine and then use their intuitive moral compass to say, no, this is good, this is bad, I think we shouldn't do this, or we should prefer A versus B. So I think it's a good way to get people to start thinking about these questions. And then the 7 principles are used to help those people consider different aspects of the problem. And sometimes these aspects can be contradictory, right? So sometimes privacy can come in contradiction with well-being because, maybe I get a service that's good for me, maybe a medical service, but it might be at the expense of a bit of privacy. So it's important to get conscious that it's in many cases these things are not black and white.
And have you given any thought to, one of the things that we think about, our starting point within our own teams when it came to our first algorithms was just simply starting conversations and making sure that we thought about the outcome or the application that we're building, and what are the stakes involved? Like, what are what's the decision that's being made, and is this going to be used to open a door of opportunity or close a door of opportunity for someone in the world, and versus maybe like a small recommendation for movie recommendations where the costs aren't very high, but also that still highlights that a lot of, I'd say, like morality and ethics is also cultural. And so you've got a starting point with these the principles that you're writing, but do you think this should be global, or is it going to be very Western?
Oh, this is like a really difficult philosophical question. I have an opinion on this, and not everybody agrees with me.
Now's the time. Let's make sure it's recorded.
Not everybody agrees with me. So, of course, there are cultural differences, but I have a strong belief that there are some very basic, primitive moral sense built into us in our genes. And one way to see this is with studies on other primates or across different cultures, where you see the same kind of reactions to very, very basic scenarios in which a sense, for example, of injustice is emotionally, happening because we feel it, right? And it's not just something we've been trained, it's something that's built into us. And if that's true, okay, it's a hypothesis, then even though the particular moral judgments will be colored by our culture or even our personal experience, traumas, whatever we have, I believe that there's a shared moral basis that most humans have in common, and so I think we should strive to build universal, like planet-wide principles, and we've done that to some extent already. If you look at United Nations principles, humanitarian principles, of course it's very tainted by Western thinking, but I believe that lots of this is actually very general.
Good, well-navigated answer. So thank you. I think that one of the things that
and I want to add something to this.
Yeah, sure.
There's another reason why I think we should strive for more universal principles, and it's because if we leave too much room to the sort of relative culture, moral thing, it's opening the door to, say, governments which simply don't want to be ethical in their behavior, to just say, oh, but in our country it's different, right? I think it's just an excuse most of the time.
Sure, and I think that's fair, but I'd also argue that I think that door's already open. It's not that they're going to open that door.
Yeah.
And one of the challenges that hits us right away when we're thinking about wanting to build sort of ethical and unbiased algorithms is right away when you start debating ethics and morality within your teams, you realize that if you want to sort of document your own humanity, you realize that we aren't very good at even understanding what we do right now. And that until you get some agreement, you don't know what to actually write into the program already. And I think
that's right.
For me, it's been an interesting way to sort of shine or put a mirror back on society.
So a crucial element, crucial reason why it's so important to regulate how machine learning is going to be used in society is because current AI systems and foreseeable AI systems have a total lack of morality, right? I mean, and so it has to be humans in the loop. It has to be humans bringing in the human context. There's no way around. And I want to go back to a question you raised, which I didn't really address, which is how do organizations start, dealing with this, companies in particular. And I think it's by investing time of people to start thinking about those things and then having the conversation with the leadership of the company and the whole company, ideally, to bring up make those recommendations actually acted upon. There's a large literature out there already that people who have, say, whose job would be to think about those questions can refer to. So, there's lots of things that's being written by people in sociology and psychology about technology, about AI now more and more. So the first step is to go and read and try to understand those issues, and then, okay, in my organization, what does that mean, right? What are the things we're doing where those issues come up? And then start the discussion with the whole group.
Excellent. I mean, I think that's why we felt it started organically for us as a machine learning ethics committee. I was really thrilled, but also surprised that a group of a lot of our people wanted to use one of our hack days times to go work on something that seemed very sort of academic and almost legal, and they weren't doing any coding. But it was excellent that culturally this company had a group that wanted to invest time in that and continues to invest to build at least our first draft of our machine learning code of conduct. One more question for you. So when you reflect on your career and all of the sort of amazing sort of research accomplishments that you have, do you ever worry that something that you've developed is going to be used for bad?
Yes.
And so how do you because you've had such a huge impact, and if this moves too quickly, what are you most concerned about? And sort of like any of your sort of discoveries getting out of hand?
The physicists in the late 30s and 40s, Einstein and company were having those qualms, right? And I think AI now has to face similar questions. I've been very active in steering up the issue of killer robots and writing letters to governments and international letters and so on, and recently had a positive impact on decisions made in South Korea about research, academic research aimed at killer robots with the Korean army. Anyways, so I think we can do things to move the world to a better place. I'm generally concerned that our collective wisdom isn't moving as fast as our technical power, and so having those kinds of discussions like today, I think, is really, really important. It has to be more than discussions. I think eventually those things become practice, become law. I'm encouraged by seeing governments, Western governments, suddenly paying attention to this. So I was at a pre-G7 meeting with ministers around the question of AI and regarding social impact. It was almost a consensus, except for the United States.
You're welcome. Yes.
That governments should really be proactive and not wait for bad things to happen. Otherwise, we would lose the trust of people in technology. I think it's a no-brainer, and we have to do that.
Great. We'll open it up to some audience questions now.
Anyone?
Oh.
No, we have a nice microphone here, and I get to throw it at you. Incentive? Oh, of course.
There's one in the front too, Katie.
Where's the one in the front?
I thought you wanted to ask.
Here.
That's one. As you were saying earlier, with the problem that this field is facing with a lot of academics being poached by the industry, how do you see the landscape of universities in terms of their impact on educating future like data scientists? Do you see that kind of changing in the near future, or is it going to, like, any predictions?
Well, if what's going on in Montreal is sort of representative of what is happening elsewhere or what will happen elsewhere, there's a huge demand for training in data science, in machine learning, and AI. We're on the path to double the number of machine learning professors at MILA, so that's McGill and Montreal and Polytechnique, HEC. So, and I see things like this happening in other places. Maybe we're a bit ahead of the curve, but it's a number of education programs are being created to cater to the needs at all levels. So it's not anymore just PhDs and postdocs. It's professional masters. We're in discussions with CJEPs so that they would have AI courses. I think there's a huge demand and a huge need, and hopefully within a few years this will help to reduce the costs of hiring people with that expertise for companies, and this is an issue for Canadian companies. That's how I see it.
Related to that, how do you think about Canada's leadership position in sort of machine learning and AI globally? I participate in a lot of discussions where we sort of spend a lot of time thinking about, this is so much of the contribution of sort of like modern AI has come from Canadian research.
Yeah.
And really like wondering if there are ways that we can maintain Canada's sort of thought leadership, ownership. Do you have thoughts on how we could do better at that?
Yeah, I mean, I've been thinking about this for a few years now. That's one reason why I decided to stay here in Canada, in Montreal, and in academia, because I think I and others can have an influence in steering Canada towards not just leadership in the science of AI, but also in the economic leadership that comes with it, and the moral leadership that we've been discussing today. I think Canada is really well positioned to be playing such a role, and it's going to need a sort of discussion and coordination between actors which don't always talk to each other, from industry, from academia, governments, and I see other academics who think like me, who think that it's the science is now moved out of universities and into products, into industry, and so we have a role to make sure it happens in the right way. It's not just a moral question, it's making sure, for example, that Canada creates an ecosystem with lots of startups that can take advantage of that. One reason why I think it's important for Canada to do that is because there will be costs to the automation that AI will be bringing, and in order to pay for those costs, to pay for the social safety net, which will have to be fixed, or the extra training, we need our governments to get the money from somewhere. And that money, the only reasonable place is from the growth that's going to come, the wealth that will be created. But if that all happens with American companies selling products from California and Chinese companies selling products from China, we're just going to be consumers, and we're not going to have any of the revenues from that.
Great.
I've got actually two different questions for you. The first one, or they are two related, but the first one is, how long do you see, how far away do you see us reaching AGI, Artificial General Intelligence? And
can I do one question at a time?
Yeah, sure.
All right, because otherwise I forget the first one. I don't know. And people who tell you they know are lying. Seriously.
Okay.
There's so much unknown about science in general in the future. When will we discover X, Y, Z? It's crazy. Like, we don't know. We can barely predict the path for the next few years in terms of how the current science will be translated into products and services. But even there's a lot of unknowns, social barriers and all kinds of things. So it's totally impossible. There's a nice mental picture that I like to repeat to help us understand why it's impossible to predict that. Right now, it feels like we're climbing this hill, this mountain, and it looks like we're making a lot of progress. But based on our past experience, we know that once we reach a bit higher on the flatter part of the hill, we'll suddenly realize there's another hill or another mountain, behind. And then we'll have to climb that one. And then, of course, there'll be another one, right? So it's impossible to tell. Next.
Okay. Well, the next question was related to that. So,
yeah.
And it's basically what would be the
but the when is very unclear. The if is almost sure, but it might take 1,000 years or it might take 20 years. I have no idea.
Yeah, because yeah. So I'm very worried that happens in my lifetime.
Yes.
Because some people have just theorized that that's natural evolution of human beings.
Yeah.
And probably no more human beings in that evolution.
Right.
So yeah, that was my second question.
Okay, it's not a question, but anyways. I'm more concerned about the shorter term and middle term things that I can foresee. Also, I think there's a lot of theorizing about super intelligent machines, which is a bit in the realm of science fiction. It doesn't mean that it's not going to happen, but it's so far removed from the kind of science we know today about AI that it's very difficult to really get a handle on that. For example, the kind of machine learning we do now it wouldn't be possible for those machines to suddenly become conscious and suddenly start writing their own code. It's just crazy. It doesn't make any sense, right? It doesn't mean that people won't build such things in the future, but it's incompatible with the kind of AI we are building today. And I'm concerned that those fears and the discussions around them are steering the public conversation away from short-term things like killer robots and other things that can really be destructive in the short term.
Well, and I think that, because I get this question a lot, and I think that people confuse their killer robots a little bit.
Yeah, Terminator is not the same thing as killer robots, right?
Right.
So Terminator is the machine becoming very smart and powerful and just killing us because she's mean, right? But that's science fiction. Killer robots is humans programming these systems that have vision, can target a particular person based on their face, and just kill them. That's not science fiction. There's all the science to build this exists, right? So the militaries are already at work building it. It's very different. It's human mean behavior. Ill intent behavior or greedy behavior, which is dangerous right now.
Right. I think that it makes great press to talk about sort of artificial general intelligence becoming some sort of self-aware and taking over the world, but we're so far away from that it's not something we should practically be concerned about. Although I do say that...
I wouldn't say that. I would say it's good that there are scientists thinking about those questions. But I think in terms of the public discussion, the media and the politicians, it's,
And that's exactly what I was about to say too. Like, I like that there should be a group of people thinking about that worst case, because I sort of say that that's how we find the best case, is thinking about those tensions between the extremes and somebody thinking about how it could go wrong. But everyone's ignoring the fact that this technology is already incredibly powerful in some really great ways, which is it can be a weapon of mass construction or destruction already today without being generally intelligent. And what you should worry about is your neighbor who is programming that. And all the ways that your neighbor is already biased and has limitations, because arming that sort of thought process with something that is sort of relentlessly scalable is really the real fear right now. It's not the general intelligence that people worry about.
So we have one last question over here, and then we'll close it off.
Thank you. So I have a very basic question. From my understanding, if you train a wonderful algorithm, for example, a chat bot, and if this chatbot become racist, it's most probably because the input data was providing enough information to the bot to become racist. So is the problem in the algorithm or from the data you learn? And so one solution would be either you manipulate the bot, or you put an emphasis on the bias to ignore some data because you already know what is good and bad, and then you open up to another problem. Who's going to decide for that? And that's not really related to AI, but it's just a symptom of what the society is. And so when you describe a way to enforce sort of a bias in the algorithm to ignore this kind of thing, I'm very interested to know how you describe the process of designing such a thing.
Right, so I was not thinking about dialogue systems.
Yeah.
I was thinking about taking decisions on loans, or are you going to stay in prison or not? Should you get is this a fraudulent transaction? So should we hire you? So these kinds of decisions I was thinking about, where discrimination can happen.
This hold perfectly.
Yeah,
in your
but
example.
in the case of a bot that has that is imitating racist behavior, I think it's a very different situation. I don't think it's the same algorithmic solutions that will apply. And I don't know that there are good solutions right now. So the obvious one is you train it in a more controlled way. So it's like those, you're not supposed to say ugly words, dirty words to children or something. It's kind of the same spirit. So that's one way. Maybe a better way eventually is to teach, and actually people are doing that already, to train another system which can recognize that a sentence is racist or hurtful to some minority or whatever. And that can be trained in a usual way, right? It's just like supervised learning. You need data, and then you can use that as part of the training of the dialogue system, so that it gets a negative reward when it says something that would be classified as racist or discriminatory and so on. So that's, I think, the kind of solutions that people are building now.
Thank you.
Great. Well, thank you, Yoshua.
My pleasure.
Yeah. Thanks, everybody.